All right, so let's get into this. So using yesterday's stuff, let's have you guys locate in your packet where it says atomic structure bell work number 1. Atomic structure bell work number 1. Okay. I would like for you have your notes right in front of you. They're right there. I would like for you to take a moment or two. I would like you to look back in your notes. I'd like for you to tell me what is Z, what is A, how do I find the number of neutrons, can I change the number of protons in an atom, and how do I get a positively charged atom? And then if you can do the bottom here, why don't you get into that? I'm going to walk around, see how we're doing, give people a chance to get in here virtually. But you may use your notes. They're right there. But I want you to fill in as much as you can of atomic structure bell work number 1. You want to do this because this is your lecture questions for today, like this exact thing. I'm trying out a little something that I might use on our quiz on Friday, so I want to make sure that it works. So we want to do this worksheet that says atomic structure bell work number 1. I'm going to walk around, see how you're feeling. Anybody at home have any questions? Awesome. So using yesterday's notes, fill out this bell work. All right. So let's go over the top because the bottom might require a little bit of support, and that's fine. So atomic structure bell work number 1. What was Z from yesterday? Z, and you might have written it on your periodic table to help yourself remember. Z is the, you got it, the atomic number. The other thing that the atomic number is it's the number of protons, correct? Then we had A. A is atomic mass. What 2 things are in the atomic mass? Protons and neutrons. You got it. Okay. Awesome. How then do you find the number of neutrons? You simply subtract those 2 things. So you take the atomic mass, which is both of them together, and you subtract out the mass of the protons. So that should make sense. If atomic mass has both of them and you take away the protons, you are simply left with the neutrons. Or you can just say it's A minus Z. That's what we wrote in our notes, correct? Awesome. Are you allowed to change the number of protons in an atom? No, never. Okay, so the only way that we can get a positive charge is by losing electrons. So what I'm going to do here is I'm going to help you set up the first one, and then I'm going to pause, and you guys are going to do the rest of them kind of by yourself. So remember, our full atomic symbol, I'm just going to use helium as an example. You write the symbol in the middle. So that's telling you this is O for oxygen, B for beryllium, C for copper. And then remember, the A, or the mass, goes up at the top. The Z, or the atomic number, goes at the bottom. And then the charge goes up into the back. Okay? So if we're looking at O, has 16, 8, and -2. What is the first thing I can fill in? Z always tells you the number of what? Z tells you the number of protons. So let's just go ahead and take 8 and put it right there. Now, if this is the atomic mass and this is the atomic number, we said we want to do what with those numbers to figure out the number of neutrons? We simply, and this is why they set it up like they do, it's a very nice, easy math problem. If I have 8 protons, how many neutrons do I have to get to 16? You got it. Okay, so to find neutrons, you simply take the difference of those 2 things. Okay, now the hardest thing is charge. So let's try a charge here. What you see is that you have 8 pluses. Remember, protons are positive, electrons are negative. How many negative things do I need to get to? This oxygen is a total of -2. That means I need 2 extra negatives. What is 2 more than 8? 10. Okay, so plus 8 minus 10 gives me my -2 charge. Let's try another one, and then I'll leave you guys be here to try to finish the rest of them on yourself. Bottom number, the Z always tells us the number of protons. If I have, 4 protons and a total mass of 9, how many neutrons do I have? 5. Very good. Now this is going to be the other way around. Let me clear some space for myself. Okay. I have plus 4 minus how many electrons will leave me a positive 2. You got it. I heard somebody whisper it. Very good. 2. Okay. Does everybody understand? Plus 4 minus 2 gives me 2. Or think about it. Some people just do better at saying, all right, I have 4 pluses and 2 minuses. That means I have an extra 2 pluses. Okay. Last thing I'm going to let you do by yourself, but this is a neutral charge. A neutral charge. So that means your protons and your electrons are equal. Okay. So I'm going to give you another pause for a moment and go ahead and finish the last 3 here. And then I'll give you the answers and we'll make sure you're feeling good with that. All right, let me give you the answers for the last ones here. 29, 29, 35, 13, 10, and 14, 17, 18, 18. Everybody feeling good? What you're going to do right now, this happens to be your lecture questions for today. And I want to make sure that this kind of was all working here. So if you open up your Chromebooks, we will need your Chromebooks kind of intermittently for the rest of the period here because your activity is there. So in your Chromebooks, if I can pause the music, go into the atoms, ions, and isotopes lecture questions today. And this is probably how I'm going to make a lot of your quiz on Friday. So I want to make sure that it's easy for everybody. This is your bell work. Okay. So on Friday, I have a quiz on paper and I might just like put it in. So you're kind of still doing the regular quiz. You have a bank of numbers down here. Remember, we just asked, what is Z? That's the atomic number of protons. So you should, everybody should get a 6 out of 6 on this because you have the information. You just did it. So why don't you take a moment right now? And if you did not get the lecture questions from yesterday, so I'm going to give you a moment. Those of you at home, tell me if you have any issues, questions, or concerns. We are putting in the lecture questions right now. So then I know nobody's going to miss the questions from today. Do anything that you've done. All right, so let's talk. So today we're going to do a little activity. The front is comparing 2 situations that you've seen. And then what would normally happen is we have these little wannabe atoms, and you would normally get up and walk around the room and count these and fill in the rest of the table. However, we're not allowed to have you like up around the room, breathing on everything that I can't sanitize between you going from one station to the other. So we kind of made a digital experience, if you will. So let me help you. I'm going to help you do the top and the first example on the first and the second page, show you how to get the third page started, and then I'll let you work the rest of the day, and we will finish this tomorrow. This is way too big to be done in one period, okay? Protons have what charge? Protons are positive. Electrons are negative, and neutrons are neutral or have a 0 charge, correct? And we said that ions are charged particles. That means that they've gained or lost electrons. If you hear the term cation, you know that that's a positive, and anion is a negative. Now, in the next step, all we want you to do is compare what an atom and an ion of the same element look next to each other. So you want your periodic table. Here it is. Let's do it. We're looking for lithium, which happens to be Li. I'm telling you here that this is a lithium atom. Hopefully you remember from your notes yesterday, atoms have a charge of 0. And this is a lithium cation of +1. So we want to know what everything kind of looks like in there. And if you have no information about the mass, you can simply use the mass off the periodic table. So let's get started. Let's locate lithium. Does everybody see him? The number on the top of his box is 3. That means he has 3 of what? Protons, neutrons, or electrons? He has 3 protons. Very good. We might as well just go with mass next because I see some neutrons. Looking on your periodic table at lithium, rounding to the nearest whole number, what is his mass? 7. Very good. What 2 things are involved in mass? Protons and neutrons. So in order to get to 7, how many neutrons does this lithium atom have? 4. You're with me. Perfect. And last but not least, if this has a 0 charge here, I have +3. How many minuses do I need in order to get to 0? Beautiful, 3. Okay. Then what I want you to do is I would like for you to draw it. Now you can either draw 3 pluses and 4 negative or neutrals, or if you want, you can say how many protons are in here. 3. And then how many neutrons are in here? 4. And then how many electrons are flying around here? 3. Because some of these are going to get rather large, and you're like, do I have to draw 27 little pluses in here? You don't have to do that. Okay. Now, all at once for you, and you're going to see these on the quiz. On your quiz on Friday, you won't have to draw at the bottom, but you're going to have comparisons like this. I want to know what changes from the lithium atom to the lithium ion. That tells me if you know what's going on inside of an atom and the charges of everything. So number 1, can I ever change the number of protons? Never. So I'm always going to have 3 protons as long as it's lithium. Would changing the number of neutrons, remember with a neutral charge, would that do anything to the charge? No. So we're going to leave that the same as well. That's mass. That has nothing to do with charge. However, what is going to be different about this ion compared to that atom? How many electrons does he have in order to have a +1 charge? He has 2, right? Because now I have 1 extra positive. So when you're drawing this, everything looks the same. 3 positives. 4 neutrals in my nucleus, but except for I have lost an electron along the way, we now have a -2 over here instead. Okay, 2 negative electrons. So you're going to go, oh, apparently I didn't white out the bottom here. Wrong way. Okay, you are going to do the bottom one on your own time. Let's go to the next one. I just want to do an example of each, so flip to the next page. Now we're going to compare 2 isotopes of each other. Let's talk about masses. Protons have a mass of 1. Electrons have a mass of 0. Remember, they do have a little bit of mass, but we just don't count it. And neutrons have a mass of 1. Isotopes, like I said, you're going to see these on your quiz. Isotopes are 2 of the same element. Perfect. Very good. 2 of the same element that have a different mass. And the reason they have a different mass is because of their neutrons. 2 of the same element with the same or different masses because one has more or less neutrons than the other. So remember, when you write your full atomic symbol, the mass goes up and to the front. So what this is telling me is that this is carbon with a mass of 12. And this one's carbon with a mass of 14. I just want you to show me what the difference is between these 2 isotopes of each other. So we're going to get out our periodic table. We're going to locate carbon. Got him. How many protons are in carbon? 6. Thank you. If it's carbon 12, these are the two things involved in mass. How many neutrons must I have? 6. It's going to give us an eerie number today, but that's fine. If you have no information about the charge, you can assume the charge is neutral. So if we assume that that's neutral, I have protons and electrons are equal to each other. So that is also 6. Okay, if you don't know anything about the charge, just make it neutral. Now, what is going to change? Oh, and we can draw this in here. Let's see. Protons, 6. Neutrons, 6. Electrons, 6. What is going to change from my isotope 12 to my isotope 14? Can I ever change the number of protons? I may not. 6 protons. Would changing the electrons do anything to the mass? No. So those are always going to be 6 as well. Remember, these have no mass. Okay. So how many neutrons must I have to now have carbon 14 instead? 6 minus 14 gives me 8. Okay, making sense. So remember, these two numbers need to add up to that number. So the only thing that's different, I still have to have my nucleus have 6 protons, but my neutrons now look different, and my electrons did not change. Okay, so there's another example of that you're going to do on your own, again, in your own time. But what I want to do is I want to get you started on the last sheet, and then everybody's going to just work, and we're going to fill this out, okay, as we go. And you know what, to be honest, I think let's make sure everybody, let's have you guys, I'll have you do the first 10. Well, you might actually, you want to know what? You might need that for the post-lab questions. Just kidding, we'll do them all. It's okay. We got plenty of time. All right. So what we would normally do is you would normally walk around the room and you would come up to this Petri dish that has beads in it, and they would be representative of an atom. This is what an atom would look like if you could see it up close. It's a poor representation, but that's okay. Because we can't have you walk around, what I need you guys to do is I need you to go into the Tuesday folder, and the stations are now virtually for you. So those of you at home can also go into the Tuesday folder. And so this is what the station would look like if you were standing up next to it. So your packet here says station number 1. Let's count the number of protons. So when we're looking here, the protons are the red beads. So I'm going to count 1, 2, 3, 4, 5, 6, 7 protons. So in my packet, the first atom at station 1 has 7 protons. Then it wants me to count the number of neutrons. The neutrons are the blue beads. 1, 2, 3, 4, 5, 6, 7 neutrons as well. Isn't that fun? Then it asks me to count the electrons. Let's see. The electrons are the small green beads. In a normal atom, they would be all over. However, it casts a shadow. So we put them all on one side to make it easier. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 green beads. So you can do this one of two ways. You can just go through all the stations and count everything first, and then come back and do the data, or you can do the data as you go along. Let me help you out here. The protons can tell me what element it is, right? So if you want to circle up the first column, that's going to tell you what element you have. So take a look on your periodic table. What element has 7 protons? Nitrogen. And then just to get you used to using the symbols, the symbol for nitrogen is N. Perfect. All right, now, a lot of people just want to take the mass off of there, but whoa, 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 we got to calculate the mass, okay? Remember, the two things that are in mass are protons and neutrons, so you take these two columns, 7 and 7 will give me a mass number of 14. And then the last thing you have to do is you have to fill out the charge because it asks for the full atomic symbol. So let's remind yourself, full atomic symbol here, you write the mass, which is A, over the atomic number, and then you write the charge. So if I'm filling this out, my mass is 14. My atomic number is 7. My element symbol was an N. However, I have to now figure out the charge. Last thing we got to look at, protons are positive, electrons are negative. If I am plus 7 minus 10, how many extra negatives do I have? Negative by, perfect. I'm negative by 3. Okay, so all you're going to do is then you're going to take a look at the next slide. And he is a different atom. And you're going to say, all right, how many protons? Write it in the column. How many neutrons? Write it in the column. How many electrons? Write it down. Like I said, there's 2 ways to approach it. If you're like, I just want to count it all first, you can count it all first and fill in the first 3 columns and then sit down and do the math, or you can go along and do it as you want. It doesn't bother me which way you do it. We're going to work on this until the end of the period. And then we've got about 10 minutes so you can get a good clip going on this. And then tomorrow we're going to finish this and finish up the back. There's another page, okay? I'm going to come around, make sure everybody's feeling good. Then I'm going to attack you guys at home, make sure you're feeling good. Hopefully everybody's doing okay.